Hi, I'm Dennis Pigden, CEO of Simio. Welcome to this tutorial on using decision logic on links. We're going to build a small model here where we have parts arrive. They go through an adjustment process. Based on the adjustment, they then go to inspection. And 90% of them go on to depart, and 10% of them fail inspection and go back around for adjustment. This example is actually out of Tom Schreiber's original GPSS book. So what we'd like to do is model this using Simio. So let me bring up Simio, and we'll start off. We'll bring out a source to create the entities. Then we'll bring out a server to represent the adjustment process. And let's go ahead and rename it Adjust. And then we'll bring out a server to represent the inspection process. We'll rename it Inspect. And then we'll bring out a sink. Then we'll add paths by double-clicking on path. That puts me in path add mode, so I'll apply a path from the source to the adjustment server. And then from the output of adjustment to the inspect station. And then from the output of inspect to the sink. And then a second path for those that fail inspection will bring around and come into the input side of the adjuster again. Then right-click to get out of path add mode. So there's our basic flow. Now, what we'd like to do is to control how the entities come out of this node, and we'd like 90% of them to come to the sink and 10% of them to go back around. Now, to do that, we're going to click on the node, and on the node, we have routing logic. And by default, the routing logic is to take the shortest path to the destination. Now, we haven't set a destination for these entities. So it's going to, by default, do random selection instead. But if we had set a destination, then the entity would go to its destination and would take whatever path was shortest to get there. In our case, what we're going to do is we're going to change the outbound link rule to by link weight. And what that does is it looks at the weight that we've assigned to each link and then randomly picks between the two links based on that weighting. So to set the weight for the links, we click on a link and we can set the weight to any expression value. So we'll set this weight to 90, and then on the other link we'll set the weight to 10. Now we could have entered 0.9 and 0.1, it would have the same effect because the probability of picking a particular link is its weight divided by the sum of the weights of all the links that are outbound from that node. So in this way, we're going to have 90% go this way, 10% go this way, and let's run the model. And we'll switch to 3D mode here, and we'll see every once in a while we have an entity, let's slow it down a little bit, that will fail inspection and go back around again. Now, one thing I should point out let me stop the model here, but one thing I should point out in setting these link weights is that the link weights can be expressions. So you could put a condition, for example, if this is part type A, go this way. If it's part type B, go this way, and control the branching in that way as well. So thank you for attending this tutorial, which is a quick introduction to branching logic on links. If you'd like more information, give us a call, and we hope you continue with the tutorials. Thank you.